2 days ago, something extraordinary took place in our solar system, and the world barely noticed. An object, unlike anything we've ever seen before, passed dangerously close to Jupiter, threading a needle through its gravitational sphere of influence. It came within a mere 100,000 kilometers of Jupiter, an event that should have made headlines across the globe. Yet, there was no probe launched, no mission sent, no press conference held by any space agency. The world's space agencies, usually quick to release information about such groundbreaking events, remained eerily silent. What makes this even more baffling is that the data collected before, during, and after this flyby has barely seen the light of day. Some of this data is locked away in preprint servers, and other critical findings have been quietly confirmed by a spacecraft already in the perfect position to observe it. Yet, no one is talking about it. But now, a new study published this week is completely reshaping everything we thought we knew about this mysterious object. What I'm about to share with you is based on peer-reviewed papers and verified mission data. There's no wild speculation here. By the time you finish this video, you'll see why more and more researchers are no longer referring to this object as a comet. And here's where things get really interesting. This object, which is now being called 3I Atlas, is between 10 to 12 billion years old. Yes, you read that correctly. 10 to 12 billion years. To put that into perspective, the universe itself is 13.8 billion years old, and our solar system is only 4.6 billion years old. That means 3I Atlas is nearly 3 times older than Earth. It was formed before our sun even existed. But that's not all. This object was born during the early stages of the Milky Way galaxy, when stars were just starting to form and the galaxy was metal-poor and chaotic. For 10 billion years, it has drifted through the vast emptiness of space, traveling across the galaxy without ever being detected by any telescope. Until now, and now that it's here, we're seeing it up close for the first time, thanks to the power of modern telescopes. So, why is this ancient object only just arriving in our solar system now, after 10 billion years of travel? And how did we manage to detect it at the precise moment it passed through our cosmic neighborhood? The odds of this happening are astronomical, but here we are, facing something truly remarkable. The scientists who studied 3I Atlas used the James Webb Space Telescope, JWST, to measure its isotopic composition shortly after it made its closest approach to the Sun, known as perihelion. What they found was absolutely shocking. 3I Atlas has a higher concentration of deuterium, a heavier isotope of hydrogen, than any other comet we've ever studied. In fact, it's higher than anything found in our solar system. But that's just the beginning. The carbon isotopic ratios found in this object are completely outside the range of anything in our cosmic neighborhood. These readings are more than just numbers. They act like a chemical birth certificate for the object. And this birth certificate tells us something truly mind-blowing. 3I Atlas wasn't formed under normal conditions, like a typical comet or icy body in our solar system. Instead, it formed in conditions that were extremely cold, colder than Pluto, and metal-poor. Just like the early Milky Way galaxy, this means that 3I Atlas wasn't formed in the outer solar system or ejected during planetary formation. No, it was formed in the early galaxy 10 to 12 billion years ago, when the interstellar medium was devoid of metals like iron and nickel. So, what does that mean for the journey this object has undertaken? For 10 billion years, it's been traveling through space, unaffected by the conditions of our solar system, and now it's here, a living fossil from the early days of our galaxy, offering us a glimpse into the past. But there's more to this story. Researchers have concluded that 3I Atlas is not just an ancient object, it's representative of an entire class of objects known as planetesimals. These planetesimals are the building blocks of planets, and they were ejected into interstellar space during the early, chaotic stages of planet formation. This implies that there are more objects out there, just like 3i Atlas, drifting through the galaxy, objects that are just as old, just as ancient, and just as mysterious. But here's the kicker. None of them have passed through our solar system in recorded human history. Why did 3i Atlas show up now? And why, of all the places in the galaxy, did it come here right when we had the technology to detect it? The odds of this happening seem almost impossible. But we're not done yet. There's much more to this incredible story. Now that we've established just how ancient and mysterious 3i Atlas is, let's delve deeper into the data we've collected and what it reveals about this object. By the time the James Webb Space Telescope, JWST, had collected the data on the isotopic composition of 3i Atlas, it had already passed perihelion and was heading out of the solar system, making its way toward Jupiter. But just as this object passed through our solar system, it was closely observed by another spacecraft, the European Space Agency's JWST, Jupiter Icy Moons Explorer. JWST was perfectly positioned to study 3i Atlas shortly after it passed perihelion. The Janus camera aboard JWST captured some of the first detailed images of 3i Atlas, revealing its bright central coma and its long tail streaking away from it. These images provided us with a new level of detail that ground-based telescopes and even the Hubble Space Telescope could not match. However, the pictures are just the beginning. JWST didn't only carry a camera, it also carried spectrometers, particle detectors, and magnetic field sensors. These instruments were designed to do more than just photograph 3i Atlas. They were built to analyze the object in ways we've never been able to before. They were supposed to return chemical fingerprints, electromagnetic signatures, and particle environment measurements that would tell us exactly what 3i Atlas is made of and what surrounds it. But here's the kicker. The data collected by these instruments hasn't been released to the public yet. ESA confirmed the observation and released a picture from the Janus camera. But the rest of the data, the crucial readings that would give us a full understanding of this object, have been kept hidden. Why is that? What could this data reveal that hasn't been shared with the world? This secrecy only adds to the mystery surrounding 3i Atlas, and it makes us question what exactly the space agencies know about this object that they're not telling us. One thing is certain. 3i Atlas is not just a typical comet. It's something much more extraordinary. And the more data we gather, the more we realize how unique it truly is. Let's turn our attention now to Jupiter. On the 16th of March, 2026, only 2 days ago, 3i Atlas made its closest approach to Jupiter at a distance of 53.6 million kilometers. On paper, that sounds like a significant distance, but here's the interesting part. Jupiter's Hill sphere, the region where Jupiter's gravity is stronger than the Sun's gravity, extends out to 53.5 million kilometers. This means 3i Atlas passed within 100,000 kilometers of Jupiter's gravitational influence, a mere hair's breadth away, in cosmic terms. This is no coincidence. The odds of an object coming from outside our solar system and passing so precisely through Jupiter's gravitational boundary are incredibly low. It's a 1 in 10,000 chance, assuming the object's trajectory was random. But here's where things get even more fascinating. The flyby was close enough for Jupiter to exert a measurable gravitational force on 3i Atlas, altering its trajectory without capturing it. This maneuver, where an object uses the gravity of a large planet to accelerate and change its course, is called a gravity assist, or a slingshot. We've seen this maneuver used many times by human spacecraft like Voyager, Cassini, and New Horizons to gain velocity on their journey out of the solar system. But what's so intriguing about 3i Atlas is that it didn't execute this gravity assist on its way in, it did it on its way out. As it was leaving the solar system, 3i Atlas used Jupiter's gravity to accelerate its speed, as if it had somewhere specific to be and needed to get there faster. The current trajectory data shows that after this gravity assist, 3I Atlas is now moving away from the solar system at a speed of over 60 kilometers per second. Where is it going? We can't say for sure. Interstellar space is vast and uncharted, and with our current technology, we can't precisely map the object's outbound path. But here's the thing. Scientists have been tracking the acceleration of 3I Atlas throughout its journey, and they've documented some unusual, non-gravitational forces at play. These are forces that can't be explained by solar radiation or outgassing alone. An object experiencing such unexplained forces should be following a deflected path. Yet, the data shows that 3I Atlas's trajectory remains remarkably precise, as if the forces acting on it were controlled and applied at exactly the right moment to keep it on a specific course. This suggests that whatever is influencing 3I Atlas, it's being directed in a way that goes beyond natural forces. Let's talk about a proposal that's been quietly making its way through the ranks of aerospace experts. There's a mission concept currently under active evaluation that proposes catching up with 3I Atlas before it becomes unreachable. The proposal comes from an orbital mechanics team who has carefully studied the object's trajectory, and they believe that with the right technology, it's possible to intercept 3I Atlas. The mission would rely on solar sail propulsion, existing launch infrastructure, and a meticulously timed trajectory to catch up with the object before it leaves the solar system for good. While this may sound like science fiction, the team behind the proposal has crunched the numbers, and they believe it's technically feasible. Of course, it's not going to be easy. The window of opportunity is extremely narrow, and every day that passes makes it harder to catch up with 3I Atlas. The object is moving farther away, and the delta V, the change in velocity required to catch it, increases with every passing day. But the mission concept exists. The trajectory has been mapped. The solar sail propulsion system has been designed. The only thing that's missing is a decision, an official decision to launch. Now, here's where things get even more intriguing. There's a version of this proposal that suggests the delay in launching the mission might not just be due to bureaucratic processes or budget cycles. Instead, there's a theory that someone inside one or more space agencies has already seen the full data collected by the JWST spacecraft. Not just the picture, but the spectral data, the particle measurements, and the electromagnetic signatures that were gathered by instruments designed specifically to study icy bodies in space. And when they looked at that data, they realized it was too strange, too anomalous to release to the public. They saw something that didn't fit with anything else we've observed in our solar system or beyond. And so the decision was made to stay silent, to delay the mission, and to prevent the data from being made public. Could that be the reason why 3I Atlas hasn't been studied further? It's a possibility that we can't ignore. As we continue to unravel the mystery of 3I Atlas, one thing becomes abundantly clear. There are anomalies at every turn, and they are all starting to build a compelling case. One of the earlier documented anomalies in the object's composition was its chemical fingerprint. Prior to perihelion, scientists discovered that the gas cloud surrounding 3I Atlas contained an unusual amount of nickel. In fact, the amount of nickel was greater than iron, and the ratio was consistent with industrially produced nickel alloys, rather than anything that could have naturally formed. This is bizarre, especially when you consider the fact that 3I Atlas formed in the early stages of the Milky Way, when heavy metals like nickel were extremely scarce. In the early galaxy, heavy elements like iron and nickel hadn't been spread throughout the cosmos yet. The first stars hadn't even begun the process of stellar nucleosynthesis, the process that creates these elements. If 3I Atlas really did form 10 billion years ago in this metal-poor environment, where did the excess nickel come from? There are two possible explanations. Either the nickel wasn't part of the original object, meaning it was added from an outside source, or the assumption that the early galaxy was metal poor is wrong. But here's the problem. These two ideas contradict each other. The isotopic ratios of 3I Atlas point to its formation in the metal-poor early galaxy, but the nickel concentrations don't match that scenario. So something doesn't add up. The data is contradicting itself, and when data doesn't line up, that's when we start to question what's really going on. But the anomalies don't stop there. The organic molecules detected in 3I Atlas provide another piece of the puzzle. These complex carbon-based compounds, which are commonly associated with biological chemistry, began releasing at an accelerating rate after the object passed perihelion. To survive the harsh conditions of interstellar space for 10 billion years without being destroyed by cosmic radiation, these organic compounds would have to have been protected, buried under at least 10 meters of shielding material. This shielding had to have been precise, covering the organic molecules from every angle to protect them from the relentless bombardment of cosmic rays. What's even more strange is the fact that the object seems to have a kind of sealed container around these organic molecules. The heat of the sun triggered something within the object, unlocking the shield and releasing these molecules into space. This wasn't a random process. It was as if the object had been designed with this mechanism in mind. Ice and rock can provide some protection over time, but they break down under the extreme temperature changes of 10 billion years in space. So what could have kept these organic molecules sealed and protected for so long? And why was this mechanism triggered only when 3I Atlas reached perihelion? The answer could be more complex than we imagine. As we piece together the anomalies surrounding 3I Atlas, one question looms larger than all the others. What does all of this mean? At what point do all these strange coincidences stop being just that coincidences and start pointing to something else entirely? When you consider the trajectory, the rotation axis alignment, the jet symmetry, the nickel chemistry, the organic molecules, and the unprecedented polarization of the object, it's hard not to ask, could this object be something more than a naturally occurring comet? Avi Loeb, the head of Harvard's Galileo project, has developed a framework for evaluating anomalous objects like 3I Atlas. He calls it the Loeb classification scale, where 0 represents a completely natural object and 10 represents an alien technological artifact representing a major threat to humanity. Initially, Loeb rated 3I Atlas as a 4 on this scale based on the anomalies observed before perihelion. However, after the full set of data was collected, including the JWST age measurements, the JWST spacecraft's imaging, and the unusual Jupiter flyby geometry, Loeb has revised his rating. Although he hasn't given a new public figure, he has indicated that the cumulative weight of the anomalies pushes 3I Atlas closer to the higher end of the scale. This shift in Loeb's stance speaks volumes. It's not just about the individual anomalies anymore, it's about the fact that they all seem to point in the same direction. Now, let's turn our attention to Jupiter's moons. Jupiter is home to 95 confirmed moons, including the 4 large Galilean moons, Io, Europa, Ganymede, and Callisto. Europa, in particular, is considered one of the most promising candidates for extraterrestrial life in our solar system. It has liquid water beneath its icy surface, active chemistry, and internal heat. When 3I Atlas passed through Jupiter's Hill sphere, it didn't just pass by Jupiter itself, it passed through the extended gravitational and electromagnetic environment of Jupiter's entire moon system. This means that 3I Atlas had the opportunity to interact, however faintly, with the magnetic and tidal forces of Jupiter's moons. And here's the kicker. If this object is carrying instrumentation, sensors, detectors, or anything of the sort, it passed through one of the most astrobiologically significant regions in our solar system. It passed through the very environment that could hold the key to discovering life beyond Earth. And it did so at a controlled precise distance. This wasn't a random encounter, it was deliberate, as though the object knew exactly where it needed to be. The final piece of the puzzle is this. 3I Atlas is fading from our view. The last image of the object taken by Hubble on March 11, 2026, showed it growing dimmer, faster than anticipated. As it moves into the outer solar system, its reflective envelope, the dust cloud around its nucleus, is beginning to dissipate. The outgassing is slowing down, and the object is closing down. If you were designing an object that needed to be visible during its inner solar system transit and inconspicuous during its outer transit, this is exactly how you would design it to behave. The window to study 3I Atlas is rapidly closing, and with every passing day, it becomes more difficult to catch up with it. A mission to intercept it still exists on paper, but whether it will be launched remains uncertain. The silence from space agencies is deafening, and it leaves us with one haunting question. Why are they choosing to remain quiet about an object that could change everything we know about the universe? We may never get another chance to study 3I Atlas up close. As it continues its journey beyond our solar system, the data will be processed, the papers will be published, but the object itself will be gone. The silence from above is telling us something, and it's up to us to decide what that silence means. If this video reached you as more than just entertainment, if it made you question everything you thought you knew about our place in the universe, then do me a favor, subscribe, leave a like, and stay tuned. Because when the next piece of the story drops, we'll be right here breaking down what the headlines want